So let's just see the question number 5. Question number 5 says obtain all the zeros of the given polynomial if two of its zeros are already mentioned to us, that is root 5 by 3 and minus of root of 5 by 3. So let's just start finding out the solution set of this particular question. First of all, what we can say that let P of x be the polynomial that is given to us, which is 3x raised to the power 4 plus 6x cube minus 2x square minus of 10x minus of 5, and we know that root 5 by 3 comma minus root 5 by 3 are the two zeros of the given polynomial p of x. It implies that x minus root 5 by 3 and x plus root 5 by 3, which is nothing but is equal to, it is of the form x, or we can say a plus b, a minus b, which is equal to a square minus b square, algebraic identity. So we can represent it into the formation of x square minus 5 by 3 is definitely a factor of the polynomial p of x. So at the end, what we can say, if these two are the zeros of the polynomial p of x, then x minus root 5 by 3 and x plus root 5 by 3, which is not of the form x square minus of 5 by 3, it is nothing but a factor of p by 3. What is the meaning of being a factor? That it can divide the polynomial p of x completely such that the remainder is nothing but is equal to 0. Furthermore, we can write this particular polynomial in the way, let us suppose I am taking the LCM over here, we can write it as 1 by 3x square or 3x square. Let us suppose we are writing it as 3x square minus of 5 is a factor of p of x. So it means 3x square minus 5 is a factor of p of x, so which also implies that 3x square minus 5 is a factor of p of x. So furthermore, we can say 3x square minus 5 is also a factor of p of x. So if it is a factor, then it can divide the polynomial p of x. So let's just divide both of these polynomials in order to get the other two zeros. So let us suppose we are dividing both of these polynomials. We have 3x square minus of 5 and we have the polynomial px as 3x raised to the power 4 plus 6x cube minus 2x square minus 10x minus of 5. So let's just divide these two polynomials all together. First of all, we have to divide the first two terms of the polynomials. So it will be nothing but x raised to the power 2. Let's just multiply x raised to the power 2 with both of these terms. It will be 3x raised to the power 4 minus 5x square. So let us suppose I'm writing it over here, minus 5x square below the term 2x square. So it will be negative, it will be positive. Both of these terms get cancelled. We will get the answer as 6x raised to the power 3 plus 5x square minus 2x square is plus 3x square minus of 10x minus of 5. Again, we have to divide the very first term of both of these terms because we can see the degree is definitely not less than the degree of the divisor. So we will get the answer as nothing but 3 into 2, that is 2 of x. So 2x, when we will multiply 2x with all these terms, we will get the answer as 3 into 2 is 6x cube minus of 10x. So it is minus of 10x. So minus and plus implies that both of these terms get cancelled with each other. At the end, what we are getting 3x square minus 5. Again, both of these terms do have the same degree. So plus 1, it is 3x square minus of 5, negative and positive. Both of these terms get cancelled. At the end, what we are getting the remainder as 0. If we are getting the remainder as 0, it means that using the factor theorem, 3x square minus 5 is nothing but a factor of the given polynomial. So at the end, what we can say, we can represent the polynomial p of x as nothing but 3x square minus 5 into x square plus of 2 of x plus of 1 using the division algorithm. we can write p of x as nothing but 3x square minus 5 into x square plus 2x plus 1. Again, we can find out the factors of all these terms as 3x square minus of 5 we have. Again, we have x square plus 2x plus 1. It is a quadratic polynomial. Using the splitting the middle term method, we can able to find out the factors of this particular polynomial. So we have to look out for the two numbers whose multiplication is 1, whose addition is 2. So it is obviously 1 plus 1. So we can write it in this particular formation. So it will be 3x square minus 5. Further, we will have x into x plus 1 plus of x plus of 1. Further, we can write it as 3x square minus of 5 into x plus 1 into x plus 1. So these are nothing but all the factors of the polynomial p of x, and in order to find the zeros, we have to substitute them as is equal to zeros. So from this particular polynomial, what we can say that root 5 by 3 minus root 5 by 3 minus of 1 and minus of 1 again. The similar zeros would be there. If we will substitute x plus 1 is equal to 0, we will get the answer as x is equal to minus 1. Again, when we will substitute it as is equal to 0, we will get minus 1. When we will substitute this is equal to 0, we will get root 5 by 3 minus root 5 by 3. So these all are the zeros. These all are the zeros of the given particular polynomial p of x. So this is all about this question.